Hi there, this is SP 6.2, probability. In probability, you have to be able to determine the sample space. You have to be able to differentiate between experimental and theoretical probability. You have to determine theoretical probability and experimental probability, and then compare the two. So down here in the indicators, observing situations relevant to yourself. So we have lots of games and things like that that involve probability. B says you have to list the sample space, and I will show you how to do that. They've given some examples here, like tossing a coin, rolling a die with 10 sides, spinning a spinner with 5 sections, randomly selecting a classmate for a special activity. So we'll give you some examples later on. C says explain what the probability of 0 would be. And D says explain what the probability of 1, so that would be 100%. E says describe how First Nations people use probability in their games. F says predict the likelihood of a specific outcome occurring, like what are the odds. G says compare the results of a probability experiment to the expected theoretical probability. So just the same as what we set up in the top of knowing what experimental probability is and what theoretical probability is, and being able to compare those two. And H basically says the same thing. I can't get my pen to cooperate. There we go. And lastly, I says you could critique the statement. Critique means tell whether it's true or not, and be able to explain why. The statement says you can determine the sample space for an event by carrying out an experiment. So let's move on to. So here we have a sample space for choosing a card from a deck. And you can see we have all the suits of cards, hearts, diamonds, spades, and clubs, and all of the cards listed from an ace to a king. So in all decks of cards, there are 52 cards. If you wanted to pull just one card out, let's say the 4 of diamonds, what are the odds of pulling the 4 of diamonds out of a deck of cards? Well, in theory, we should pick it at least one time out of 52 tries, because there's one 4 of diamonds in a deck of cards. So we would say that the odds, or the theoretical probability, of pulling out that 4 is 1 out of 52. We usually write it as a fraction. Now, if you wanted to type this into your calculator, you could, and you would see that it can give you a percent. So I'm going to type in 1 divided by 52, because a fraction bar means divide, and it tells me that it is about a 2% chance. 1 divided 52. All right, so it's roughly a 2% chance of getting that card. Down here at the coin, the sample space is only 2 options. It's either going to be tails or heads. And so the odds of getting tails would be 1 out of 2. So the bottom number of your fraction represents your sample space. There are 2 possibilities. Okay, let's look up at the dice, the green dice. How many possibilities are there on the dice? Well, they've listed them there. You could either roll a 1, a 2, a 3, a 4, a 5, or a 6. So your sample space, or all your possibilities, or all of your outcomes, would be 6. Those are the options that you've got. The odds of rolling a 3, well, there is only one 3 on a dice, so you could say there's 1 chance out of 6. Okay, let's look at our spinner. The yellow side is bigger than all the rest. So if you were to draw a dotted line there, you can say that the yellow section takes up 2 out of 4. And if we reduce that, we know that 2 out of 4 means half, and we can tell that the yellow is covering half of the spinner. So the odds of rolling red or spinning red, well, there's only 1/4 of the spinner. so it's 1 out of 4. The odds of rolling blue, also 1 out of 4. The odds of rolling yellow is quite a bit better. It's 2 out of 4, or 1/2. Let's move on to the next slide. Here we have a bag of marbles, and this is where I wanted to explain the probability of 0. So the probability of pulling out a purple marble, there aren't any purple. It is 0%. Because if we counted those marbles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we can say, well, there's 0 out of 10 of them that are purple. So that means 0 probability, which also can be written like this. It's impossible. Okay, so what are the odds of green? Well, let's count the green marbles. We know there's 10 in total, so the bottom of our fraction is going to stay as 10. And if you've counted them already, you would see there are 4 green ones. So 4 out of 10 is our theoretical probability for green. Now it's quite likely that if I reached into the bag and drew out 4 marbles, I wouldn't be drawing out 4 green ones at once. But in theory, if I drew out all 10, I should draw at least 4 green ones. So that can be expressed as a percent. It's a 40% chance that I would get green. So it is probable or possible, right? Red, you can count the red ones quick, and you'll see there's only 3 of them, and that equals 30%. So it's also possible. But of these two, of those two options, which one is more likely? Which one has the greater chance of being pulled, green or red? Well, this one has a bigger number. This is a bigger percentage. It's a bigger chunk of that fraction. 4 out of 10 is bigger than 3 out of 10. So the green would be more likely. Okay. Now, what are the odds of pulling out a marble? Well, all that's in the bag is marbles, so there are 10 of them out of 10 chances. So that's 100% likely that we're going to reach in there and pull out a marble. So we can say that it is certain. So when you're talking about probability, you're talking about possible, impossible, certain, more likely, less likely. You'll have all those words that you can go put into your journal. See you later.